The Arduino Zero is an advanced Arduino board with several very useful features. It has the same footprint as the Arduino Uno, so that many of your existing shields will fit. It is a 3.3 volt only board, so you must be careful not to connect any 5 volt devices to it without a way to step down that voltage. It is fitted with a 32-bit SUMD21G18 ARM Cortex-M0 Plus microcontroller, which means that there's plenty of computing power for many common applications. It also has a lot more flash and RAM memory than the Uno. All of its 20 input-output pins can provide PWM capability. On top of that, one pin can be used to create true analog output. The Zero has a very low power consumption rating, making it ideal for battery-powered applications. A very important feature for more complex applications is the embedded debugger chip, which works with the Atmel Studio to provide full live debugging features. This chip can also be used to program the SRAM microcontroller. The Zero has two USB ports. The programming USB port is connected to the embedded debugger used for programming and to simulate a serial port. The native USB port is connected directly to the SRAM microcontroller and can be used as a serial port or to simulate a USB device to a host like a computer or to connect USB devices to the microcontroller. Let's check out the details now. Hi, in this lecture I will introduce the Arduino Zero, or Arduino M0 Pro, as it's called depending on where you purchase it from. So the Arduino Zero, as I'll be calling it in this section and in this course, is an advanced Arduino board. It uses the same footprint as the Arduino Uno, so you can see that the headers are very similar. The Arduino Zero has a SUMD21 microcontroller, this chip right here, which is a 32-bit microprocessor. It's an ARM architecture, an ARM Cortex-M0 microprocessor, as opposed to the Arduino Uno, which runs a AVR microcontroller. It has no operating system on it, and another big difference between the two boards is that the Arduino Zero is a 3.3 volt board, which means that you got to be careful not to connect anything that is providing 5 volt power to it, or you risk damaging the board and the microcontroller on it. It's got 20 digital input-output pins. All of those pins allow you to do PWM, unlike just the 6 in the Arduino Uno. And you get also your 6 analog input pins, which also have a higher resolution. You can go up to 12 bits of analog output resolution, unlike just the 8 bits that you get in the Arduino Uno. And on top of that, you have one pin, that's analog pin 0, this one here, that gives you a true analog out capability, which I'll be demonstrating in a separate lecture as well. Great advantage of the Arduino Zero over the Arduino Uno is its power consumption. I'll be doing a demonstration of that as well. The Arduino Zero is a low power microcontroller board, so you don't get as much power to its digital pins as you do with the Uno. So you can see with the Uno, every one of the digital pins can provide up to 20 milliamps of current, but in the Arduino Zero you can only get up to 7 milliamps. You can still use that power to light up an LED, there's no problem, but obviously you need to be a lot more careful when you drive higher loads like motors, for example, or even larger LEDs and solenoids and things like that. If you do that, you'll need relays or transistors to help out with power. As far as memory is concerned, the Arduino Zero integrated inside the SRAM microcontroller, you get 256 kilobytes of flash memory as opposed to just 32 kilobytes on the Uno. and 32 kilobytes of RAM, of static RAM. There is no EEPROM on the Arduino Zero. There is this so-called emulation of EEPROM, so there is a library that you can use that can emulate EEPROM functionality, but once power is lost on the Uno, then anything you wrote on the emulated EEPROM will be lost as well. So if you need EEPROM functionality, I'd say that the best option is to have an external EEPROM connected, usually by I2C, to your board. Clock speed is 48 megahertz, so there's lots of power for fairly demanding applications. You can use this board to do signal processing if needed. If you want to, there's enough power for that. Another thing that the Arduino has is a real-time counter. This is not exactly a real-time clock. It's a real-time counter which also has real clock and calendar capabilities. So inside the SRAM microcontroller you have a component or a system that once you set it with the true time and date, for as long as there is power on the microcontroller, then it will keep the real time, and you'll be able to retrieve that in your sketches. So you don't have just the ability to count milliseconds or microseconds like you do with the Arduino Uno, but real time and date. You use the real-time counter to do that. On the Arduino Zero, there's also this large chip. This one here, this is the EDBG, or Embedded Debugger chip, which gives this board a unique capability compared to all of the other Arduino boards, and that is the onboard ability to do real-time debugging on the hardware, via hardware on your Arduino. I've got a whole lecture dedicated to this feature, but in a nutshell here, you can use Atmel's Studio application in conjunction with the EDBG chip on the board to do real-time debugging, and with that you can get access to every memory location on the SRAM microcontroller, all of its registers. You can start and stop the execution of sketches. You can inspect variables in the console variables. You can change variables. You can set breakpoints and trace points, and you can do many things that are very useful when you are debugging an application running on your microcontroller. So this is a unique feature. You can still do things like this with your Arduino Uno, but you will need an external debugger for that. The nice thing with the Arduino Zero is that the debugger is part of the board itself. So I've got a lecture about this where you can get more details and see how exactly this feature works. Other features on the Zero board is that you've got two serial ports. You've got a native and a programming port. So you can see here that we've got two USB ports. This one here is the native port, and this one here is the programming port. And let's have a look at the difference between these two ports. So I'll have a look at the schematic. So here's a schematic of the Arduino Zero board. In the first page, we've got the microcontroller, SRAM-D21G 18A, and down here you can see the first USB port. This one is the native USB port, and that is connected directly to the SRAM-D microcontroller. With the native port, you can get your Arduino Zero to behave as if it was a USB peripheral device connected to the computer. So you can get this board to behave as if it was a mouse or a keyboard connected to the computer. I'll give you a demonstration of what that looks like in a separate lecture. That's a nice thing. Another thing that you can do with the native port is you can connect other USB devices to your Arduino Zero. So you could connect a mouse or a keyboard and use it as a device to control a sketch running on the microcontroller. Of course, you can also use the native USB port to send text messages as output from your sketches to your computer using the serial.print statements in your sketches, just like you do with the Arduino Zero. You also have the programming port, the one that is closer to the bottle connector. And let's go to page number 3 in the schematic. So in page number 3 in the schematic, you see the large EDBG integrated circuit here, and then down in the corner on the left side is the programming port, and you can see that that is connected directly to the EDBG chip. So with this port, you can program the device via the EDBG. So we use the EDBG chip as a programmer for the SRAM controller. We can do the programming that way, and we can also use this port to debug the sketch running on the SRAM microcontroller via the EDBG chip. So when I'll be doing the demo of a debugging session using Atmel Studio, then the board will be connected to the computer via the programming USB interface. A really useful and powerful feature. We've got interrupts on all pins except for pin 4. We've got an ICSP programming header here, exposes the SPI interface. We've got one wire interface, serial interface. We've got the JTAG connector, again for debugging. The chip contains a DMA controller, so you can use direct memory access, and that is a way to directly transfer bytes in and out of memory without having to tie up the CPU. And finally, the header configuration of the Arduino Zero is compatible with that of the Arduino Uno, and any shields that you've got from your Arduino Uno will fit with the Arduino Zero. The only consideration, the only thing to be careful about is the voltage. So remember, this is only a 3.3 volt device, so it will only accept peripherals and components that are also 3.3 volts. At 5 volts, you're going to have issues, potential damage of your boards. So that's as far as the features of the Arduino Zero board are concerned. A couple of other interesting things to mention is that there are actually 2 versions of this board. One is sold by Arduino.cc. The other one sold and made by Arduino.org. You may know that there was a split in the Arduino community earlier in 2015, and that has caused basically a fork of the original company. So now you've got 2 companies that are selling an almost identical product with different names. In my case, I purchased my Arduino Zero from Amazon, and actually I thought that I was ordering an Arduino from Arduino.cc, and that I was actually going to get the Arduino Zero, this board here. Eventually what I got instead was one of these. So I got instead an Arduino M0 Pro. So M0 obviously comes from the name of the microcontroller. It's an ARM M0 microcontroller, and it's Pro. It's marked as Pro because of the EDBG chip here. If you go to the Arduino.org site, you'll see that down here in the products page, there are 2 variations of the M0 board. One is the Pro. It's got the EDBG chip, and the other one doesn't have the EDBG chip. It's only got the M0 microcontroller with the native USB port. So that's a big difference between the M0 and the M0 Pro. Okay, the M0 has no EDBG, it only has the USB native port, and the M0 Pro has the EDBG chip and both USB native and USB programming port. Alright, so I got the M0 Pro from Arduino.org, even though I thought I was ordering the Arduino Zero from Arduino.cc. The boards look almost identical, but there is a little difference. The thing to be careful about when you get, say, an M0 Pro and you want to use it with your Arduino.cc IDE is that the digital pin 2 and the digital pin 4 are actually swapped in software. So what this swap really means? Well, if you have a sketch that is, for example, lighting up an LED that is connected to digital pin 2, and you send that sketch to your Arduino M0, then nothing's going to happen to digital pin 2, because in the configuration files that you get with this board, the digital pin 2 is swapped with digital pin 4. So in the next lecture I'm going to show you how to fix the situation so that when you use digital pin 2 in Sketch, you actually use digital pin 2 in hardware as well instead of digital pin 4. So it's a little bit, it is confusing, but I'm going to show you how to fix this in your Sketch, in your Arduino IDE in the next lecture. Another thing that differentiates the Arduino M0 Pro with the Arduino Zero is the bootloader. So there's a different bootloader installed in the Arduino.org M0 Pro board versus the Arduino Zero from Arduino.cc. So again, in the next lecture, I'm going to show you how to install the bootloader from Arduino.cc so that you can use it with the Arduino IDE that comes from Arduino.cc, which I regard as the genuine Arduino company. So that's about it with a not very quick introduction on the Arduino Zero. Let's move to the next lecture where I'll show you how to set up your Arduino M0 Pro to behave exactly like an Arduino Zero from Arduino.cc.